Hello and welcome to EasyColorize2D. In this video, I'll show you how to use EasyColorize2D to modify the colors of your textures directly inside Unity. Unlike complex software like Adobe Photoshop that takes time to learn, EasyColorize2D makes color swapping quick and simple, all within a single editor window. With just a few clicks, you can select the color, choose a new one, and apply the change instantly. While it doesn't offer all the advanced features of Photoshop, EasyColorize2D is a great choice for simple tasks like Sprite recoloring. It saves you from the steep learning curve of other tools, making it quick and easy to get the results you need. So let's get started. First, click on the sprite you want to colorize and make sure the read-write property of it is enabled. Then, right-click on the image file and select EasyColorize2D Colorize. This will open the Colorize window. This window provides everything you need to recolor your sprites. The minimum pixel percentage setting is used to analyze the original texture. In the left column of the color selection section, you'll see the colors that appear in more than that percentage of the texture. Right now, it's set to 1%, so all these colors here are present in more than 1% of the non-transparent pixels in the texture. You can adjust this value and click this Reanalyze button to update the detected colors. So let's increase it a little bit and see it in action. You can remove any of the detected colors or manually add custom ones using this color picker. The right column in the color selection section lets you modify the corresponding colors from the left column. Any changes made here will apply to all pixels containing that color or similar shades, based on the similarity threshold value. Increasing this threshold expands the range of colors considered similar. When the Force Closest Color toggle is disabled, a pixel's color will only be changed if its similarity to the closest color in the left column is within the similarity threshold. If it falls outside that range, the pixel remains unaffected when adjusting the colors in the right column. For instance, here, if I change this blue shade, you can see which pixels are affected. Now, if I increase the similarity threshold, you'll notice that more colors are impacted as well. Enabling the Force Closest Color toggle ignores the similarity threshold entirely. Each pixel is instead mapped to the nearest color from this left column. This is especially useful when you want to recolor all shades of a color at once, and it works best with images that contain only a few distinct colors, like the example shown here. As you see here, with the Force Closest Color enabled and only this blue shade selected, all the pixels are affected. If I add a red shade, all the other red shades will remain unchanged as they are closer to it than this selected blue color. When two colors meet in a texture, blending often occurs, creating pixels that are a mix of those colors. To ensure blended pixels are recolored accurately, we use the Neighborhood Search Radius property. This setting defines how many surrounded pixels are checked to identify a dominant color for any pixel that doesn't match the selected colors directly. Setting this radius to 0 disables the blending detection entirely. In this example, the blending around the shark's teeth is working correctly because the Force Closest toggle is enabled. This causes the blended pixels to be mapped to the nearest color, in this case the red shade, so the color change is applied to them as well. But if I disable it, you'll notice that some of the pixels around the teeth retain their original red shades. One way to address this issue in this particular example is by increasing the similarity threshold. However, doing so would cause the blended pixels to be treated purely as the red shade of the tongue rather than as a blend of red and white. As a result, if you later change the white color of the tints, those blended pixels will still retain traces of white. For blending to work properly, both colors involved in the blend must be present in the left column of the color selection section. Even if you don't intend to modify one of them, it still needs to be added so the system can correctly identify and process the blending. So let's go ahead and add the white color we have for the teeth. It's improved, but there are still a few pixels left untouched. Let's try increasing the neighborhood search radius to 2 and test it again. Perfect. You can see the results now, and we can go ahead and change the tongue's color to any other color to test it even further. To handle blending with other nearby shades like this darker red, we'll follow the same approach. Just pick that shade as well. And here is the result. The blend threshold property determines whether a pixel's color should be considered a result of blending between nearby dominant colors. Increasing this value can help catch more blended pixels, but may also include unintended ones. In most cases, the default value should be sufficient. Now let's speed things up and finish colorizing the rest of this image. And we're done. Once you're happy with your color changes, click the Export Texture button under the Output Texture to save your new sprite as a PNG file and use it in your project. I've also included more colorized examples of this cute shark as screenshots on the Asset Store page for you to check out. Don't forget to check out the other tutorial videos where I demonstrate the colorization process on more complex images. I've also included some helpful rules of thumb in the documentation to guide you on how to fine-tune these settings effectively. You can find the links to them pinned in the comments section down below. Thanks for watching. If you have any questions about the asset, feel free to reach out to me using the comments or the email provided on the Asset Store page.